Hello, welcome. It's the next episode of the Devlogs. Don't know what episode it is, it doesn't really matter. So, what did we do last time? Basically, last time we managed to do signal payloads. So, for the ball hit, yeah. So, for the event handler for the ball hit, we managed to do a single payload instead of having multiple arguments. We just have one. So if there are any more future arguments that I need to pass in for certain files, instead of having multiple args, we'll just have one arg. We'll edit, add it to this, and then that way we don't have to edit every single file that calls that event. So we've done that, and we managed to have screen shake, which we did inside game fill. So we got the on ball hit, do hit stop, that's a print statement, add trauma, which is this method, and then in process we add the we decay. So in process we're decaying the screen shake, and then we're doing a camera offset and a camera rotation for the shake. So just a quick reminder of what it looks like. I look very unprofessional if I'm leaning back. Sorry about that. Let's show my input. Take that. So this is what it looks like. Looks decent. Looks decent. Oh, yeah, and we added the deeper and harder the charge is, the more it shakes. So if it's at the tippy top, it should be smaller shake. And we've obviously that's in combination with the hit stop as well. So the ball's stopping. So it kind of combines to make it seem pretty good. So that's what we got. So what's the plan for next? So I did write this up because I didn't really know. I've got what I've got in this game. I don't really know what to do next. I feel a bit aimless, so I did write this up. Let's go here. So I do have like steps to do, so that I can like keep going in a direction. So we got short term, medium term, and long term steps. The what I'm gonna try to implement is I need a visual indication of paddle charge. That's what I'm gonna do next. That's the next step, and then we can get on to the other steps. So let's put that here. What I mean by that is, if we go to paddle color rect, this was the visual indicator before. Obviously, not it wouldn't be in the final game, but just for me while trying to play test and develop. But that gets in the way of the ball, and I don't really like the way it looks, so I turned it invisible. But now I actually do need a way to see how much it is charged, just for my own benefit. So I thought something like have like a bar. Oh, sorry. Control H. Yeah, there we go. So have like a bar, like across the sides there, so that if I charge, then it will just go down, 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 and then once it hits the bottom, then I know I'm fully charged. Release, and it would go back up. Should be fairly easy to implement. Actually, I'm not sure. Or maybe I put like a color rect here. Maybe I'll put a color rect here and then shrink it or change the color. Actually, I don't know. I don't know how, but I'm gonna have to do that. That is the next plan, and then after that, once I've implemented that, then I'll get on to other steps. So let me try get that done. Okay, so that is done. I actually did a 2-for-1 there. What I ended up doing was I did the charge meter on the right, and I also implemented a ball respawn mechanic. I've still got the press Y to respawn as a debug thing, but in the game loop, I wanted a way to respawn the ball every time the ball goes below the paddle. So I actually did both of them. My implementation. So with the HUD. Oh, also worth noting, the HUD, I wanted to make it independent from the screen shake. That was actually, I just had to make follow viewport, turn that off. It was off here. If you're here, follow viewport was off, but for some reason when I instantiated it into the main scene, is this working? Yeah. If I when I instantiated it into the main scene, follow viewport was turned on, so I just had to toggle that off. That way, when screen shake occurred, the HUD stayed still, so I can apply later on. I'll apply my own type of movement and effects to it. But for now, that's separate. That's good. For the charge bar, I went into the HUD scene, included a charge bar here, made it from top to bottom so it charges, added percentage, zero, made it 0 to 1 steps, 0.01. And so what I did was I made the paddle, where's it gone? There was a method, calc charge. And then calc charge percentage, I made that public. We went to the HUD scene, imported the paddle, and I got constants, charge normal color, charge full color. So the color that the charge should be while it's charging to full. And then once it's full, it'll be red. And then just within process, set the charge value to paddle.calculate charge percentage. That way I can get percentage of whatever. And then charge bar modulate. This is just me being able to set the color for while it's charging and when it's full. So I did that. Then for the respawn, I've still got allow ball respawn, but I've got where's my respawn method? Respawn ball. So that was before debug ball respawn. Now I call it respawn ball. Made it public. It's the same code. I didn't even have to really touch the debug thing. Then in game manager, I just check on ball lost. Originally, I actually called on ball lost if lives are less than or equal to 0, then the game's over. But if it's not less than or equal to 0, that means the game's you still got lives left. So paddle.respawn ball, I did that. I was getting a bunch of errors, and from the error messages, I asked Claude about it, and it said basically what was happening was it's a method's being called to instantiate like a physics body thing such as the ball, but because the physics process hasn't finished updating, it kind of like there's a clash, but Godot just lets it go through. So the way I did it was callable.from this method, respawn ball, call deferred. So what's happening is callable.from is making a reference to this method, and call deferred schedules it so that it waits for a safe point to do it. That's the explanation. So this is what my game looks like now. We have this. Yep, that's working. So you can see, there it is. Oh, I have to be quick now, but you can see the charge percentage on the right, and then when it hits 100%, let me just end the game. So yeah, you see the charge percentage on the right, so it's green, it shows the percentage, and then when it's 100%, it will show red, just as a visual indicator. It's not gonna be how the final game looks, but it's roughly there, so it's good for me while I play. Then I've still got my press Y. Does it show? Yeah. I still got my press. press Y for like my debug respawn ball, but in the game it actually respawns perfectly fine. So look, like that. I do want to add like I'll wait, you know, a couple seconds for the ball to respawn, but I'll implement that later down the line. For now, this is good. There is also an issue with that, with the ball goes through this. I'm pretty sure the way to solve that is just to make this collision shape 2D just a bit thicker. But for now, I'm not gonna worry too much about that. Let's respawn it. So the game's looking good. Alright, next. So that's two. I did 2 for 1 there. See. So I think it's because of this. I need to make the wall a little bit closer to the area and make it thicker. But that's for later. Alright. Next, what I'm gonna try to implement. Hopefully I can. Let's make sure I don't think. Next, what I want is dynamic blend. What did I call it here? Dynamic aiming blend. So if you recall before with my paddle, where is it? We've got this thing called strike direction blend. So we actually had 2 ways of solving. There's actually 2 ways of solving a certain issue. So we got this. Let's try to do the same thing. Okay, so if the ball's here for each, there is a method where I can just check the ball's when I'm striking the ball, I can check the direction of the ball of where it is in comparison to the pivot and just strike the ball in that direction. Or I can take the ball and see, okay, the wedge is being aimed this direction, so just when striking the ball, strike it in parallel to that position. And the final product that I got is a blend between 2, so it takes both into account and kind of like, okay, it's this direction and the aim is that direction, so it blends it to here. What I want, and I'm going to try to implement, is actually dynamic blending. So what does that mean? That means, oh, that's a massive circle. That means we got our pivot. And we got our wedge. The aim is here, so that's where the player's aiming. What I'm gonna have is if the ball is here, then it will take into account more the direction aiming, the direction of where the ball is from the pivot, rather than the aim. Hope that makes sense. Whereas if the ball, let's undo that. If the ball is here, closer to the pivot, then it's more in line with that. So depending on how close the ball is to the pivot on strike will depend on how much that blend is. So dynamic blending. I'm going to try to implement that. I know that just like doing the theory inside my head, I know it will have to be inside paddle. We've got our strike direction blend. Oh, hang on. Direction blend. There we go. It's over. So it's 0.5. Oh, what did I set it to? I set it to 0.3, didn't I? 0.3. So let me set it to 0.3 here just to keep it consistent. So you can see 0 means purely positional, 1 is pure aim. I've got it at 0.3. So to do the dynamic, so this is not dynamic. To make it dynamic, I'm gonna have to on ball hit do something. So I'm gonna try to do this, figure out a way, and then I'm gonna get back to you. Alright, so that's sorted then. That wasn't that difficult at all. It seemed like in my head it would have been much more difficult, but when looking at what I already have and how it's working, it was actually pretty simple. So originally, I still have the export, which I'll get rid of. But originally we had strike direction blend, which meant it was a value between 0 and 1, 0 being purely positional, 1 being pure aim. Strike direction blend is being used by, let's find it. Yeah, calculate strike direction. And so everything was the same. Then it was this line that was taken in the strike direction blend. So I thought, okay, trying to figure out the strike direction, it's between the positional direction, aim direction, and then finding out the blend between them, which is manually set, but essentially I just want to dynamically set that. And the way it's done is I made a new variable called ball to pivot proximity, and I realized, well, I've got a method that calculates that, and it calculates it as a percentage called calc proximity percentage. So we've already got pivot to ball that gets passed into this. So we get pivot to ball dot length, that gives us the distance. Calc proximity percentage, that gives us the percentage of how close it is to the pivot. 100% being 1 being 100% being it's at the pivot, and 0 meaning 0% meaning it's at max radius. So obviously I want it, if it's closer to max radius, I want it to be purely positional, and if it's at pivot, for it to be pure aim. And it's already set up like that as a percentage, because percentages in C sharp is, or at least in godot, the way I'm doing it, it's 0 to 1, and you actually just get 0.1 or 0.2 or whatever. So plug that directly into strike direction, ball to pivot proximity. I'm explaining this horrendously, I know, but it's really hot. I'm really, I just ate as well. So, anyways, the point is, it was just 2 lines. It was ball to pivot proximity. Use a method that I already have. Plug that directly into how I calculate the strike direction, how I was doing it before. And yeah, and it works. So let's go to the game. Can't remember if I've done something else, but anyways, let's do my game overlay, my input overlay. Okay, let's play this, and there we go. So if it's at the edge, it should be more positional, and if it's closer to the thing, it should be more aim directed. And it kind of works, and the way it feels like in order to play, feels really good. I like it. It feels better than before. Before it was just uniform, a 0.3. At the bottom here, you could see the new strike direction blend, which I'm calculating at runtime, depending on where the ball is, and you'd be able to see the values here. Before it was just all a uniform 0.3, but now you get a variable rate. Now, if you're playing the game and you want to, oh, this is really difficult, and you want your aim to matter as much as possible, then you're gonna have to let you have to risk the ball being close to the pivot, and as you can see here. But yeah, it's starting to feel good. So you see that. Oh, let's just play with this on. Yeah, I like it. Now, what is next? It's really hot. I'm really tired. I want to call it a day. but I'm not gonna. I think I can do one more thing because that one was relatively easy. It was just more just reading through what I've got. Actually, beyond that, since so I can get rid of that. We can get rid of this debug print. Blend the two depending on get rid of that, and I think it's called direction blend. It's right direction blend. We can get rid of that. So next on the docket, what's next on the docket? So dynamic aiming blend. That is done. We've done 4 things today. Actually, that's pretty good. But this one I'm gonna try to do is let's go here. Let's get rid of my enholder. The next one is wedge buffer. I've been speaking about it for a while now, but essentially, when I play, because the ball is coming at such a fast speed, right? Let's say that's the ball, and I strike and the ball's here. But because it's coming at such a fast speed, it feels like when you're playing the game that it should be a strike. Now, obviously, it's not a strike, and it's just outside. But it feels, but it feels a little bit too harsh. So what I want to incorporate is some type of buffer. So like, I don't know, like 10% buffer. So that if the ball is within this 10% buffer, then count it as a strike. Because I think if the game was slower, yeah, I think if the game was slower, I wouldn't need this. But since the ball is coming at such a fast pace, when you strike the ball and it's around the edges of the pivot, I'm sure internally it's calculated that it's not inside the pivot, but visually it feels like it's a bit too harsh. So I want to add this sort of grace area where I'd allow it if the ball is there. I'm gonna try to implement that. I don't even know how, so I know it needs to be inside paddle, that's for sure. Maybe have a like buffer. I'll definitely have like an export tuning value, which is the percentage of how big. Actually, I don't want it to be a percentage. I'd want it to be pixels and how big that should be. Have a tuning value, and then I don't know. I'll figure it out. So I'm gonna try to do that. Okay, so I have implemented that. It was something simple. So we've got our, where's it gone? I've got 2 things that I added. I've got let me calm myself. Sorry about that. So I added an export field, wedge angle buffer degrees. That's the amount of degrees, that's the buffer. I also added show wedge buffer, set that to true, and that's for debug, so I can toggle on the wedge buffer. Within draw, I'm checking whether show wedge buffer is true and wedge angle buffer degrees is more than 0, so there's actually a buffer. And essentially I've just taken this code and refactored it for the buffer and just made it a bit darker. That's all I've done. And what's the other thing I did? It was in try strike ball, that's right. In try strike ball, we had our previous code here, and all I'm doing is I'm taking so all of this stuff was there before already. I added buffer radians, so taking the wedge angle buffer degrees, converting that to radians, because internally it deals with angles and radians, and made the effective the half wedge radians that I've calculated already, plus the buffer radians, and just swapped out half wedge radians with effective half wedge. That's all I'm doing. So in the final build, I'm not going to turn on my input, but I will show you. So we've got half wedge buffer shown. I've set the wedge angle buffer degrees to 15 degrees. And this is what it looks like. So you can see here, let that go. So you can see here, that's our normal wedge that we got, and it's adding an extra 15 degrees each side. However, upon playing it, it doesn't really feel like it's doing much. So you can go there, but like sometimes those edge cases are really difficult. And I've played around with the degrees, like those stuff there. So that's a hit. That's a hit. That was already within the wedge. But like a hit there, it's really difficult. I've played around with the degrees. Let me turn it off for now and play it so that this is what people would see. Oh, it's supposed to be. Let me turn it. Half wedge buffer is off now, so it shouldn't show. Yeah. So let's play it. That's fine. I'm gonna try an edge case, like a risky one. See? It's really difficult. So I think it's because I want to try a different method. So let me try to draw it and explain it better. So the way it's working, got that, we got that, boom. So the way it's working, it's working. It starts out here. Let's say that's 15 degrees, and it slowly trims out. So that's the way it's working. It only counts for the left and right edge, and it's really tight towards here. What I'm thinking, or what I'm considering, is to find a way where, let's say you strike, the ball's here, you've hit strike, and it just quickly detects, it's able to calculate, okay, how close is that to the wedge? Or if like the ball's here, how close is that to the wedge? How many pixels is that? And set that to, let's say 3 pixels. And it just quickly detects it like that. So that way, all across here, it's essentially uniform, like a uniform 3 pixels. I'm thinking that would be better. So whenever a strike occurs, quickly capture where the ball is, where the closest part of the wedge is, calculate that distance, and if it's within a set distance that I've set as an import field, do that instead of this, because right now the current thing that I've got only checks the left and right firstly. Also, it doesn't check the top as well, because I think a lot of the times the ball's coming at speed. It's coming at speed, but maybe like I strike it just slightly too early, and it wouldn't really count as being within the buffer. Thing is, that's a lot of work to do and a lot of stuff to rework. I'm probably going to have to create a brand new method for that. I feel like I've done enough for today. So I'm going to leave it there for now. Yeah, so I'm going to leave it there for now. The plan for the next devlog is I'm going to try to implement a more complete buffer instead of the angled buffered, uh, rather than the angle buffer that I've got right now. That's for tomorrow. But for today, I feel like we've done a lot. What did we do today? We actually did quite a lot. So we did the charge indicator over. We managed to make the HUD independent from the screen shake. We've got auto ball respawn, which does need a bit of tweaking because I want to make it pause for a bit before it respawns, but it's still there. So we've implemented that, and we've got dynamic blending as well. So that's quite a lot of features added. I'm pretty happy with that. Like I said, tomorrow I'm going to continue working on this buffer thing, but that's enough for today. Appreciate you watching. I feel good. I'm ready to carry on tomorrow. Well, that's it for today, so thank you.